Hello everyone, welcome. This is class ECE341, the probability course. Last time we have introduced the method of counting, and today we will work on the same topic, but with somehow more complex cases. All right. Okay. It's easy. ECE341. This is the fourth week, Wednesday class. Okay. The counting method. Right? So we consider we want to pick k from n objects. Suppose we have n objects, we want to pick k from it, and we have discussed three different cases for this one. So the first one we consider with replacement. Yeah, you think like you have a box, you have n objects in the box. When you pick one out, you put it back, then pick another one, right? So every time you put it back with replacement. You can also without replacement. So when you pick some out, you will not put them back. So next time when you try to pick another object, the one you already used, you cannot use it again. Right. And you can also consider with the order. So like A and B and A, they are different. They have different order. You consider they are different. You can also consider regardless of the order. So AB and the BA, you think they are same, right? Then we consider these three cases actually. This is n to the k. N to the k. So every time you have n object, you have n choice, and totally you need to pick k times. So n times itself until k of n time together. So n to the k. And if you pick the object without the replacement, then the total amount will be denoted by this n k, which will be n times n minus 1 times totally k terms, and this is n factorial over n minus k factorial. Right. And here if we regardless the order, then we have the number is n pick k. Oh no, the other is n choose k from n, or c n k. It will be the value is n factorial over k factorial times n minus k factorial. And we have name. This one we call, this number we call, this is a combination, and this we call the permutation. Yeah. Okay. So this is what we studied last time. And here for this number C and K, actually we have a way to calculate it. It's a triangular way. So like this, we start from 1, then 1 and 1, and 1 and 2 and 1, and 1 and 3, 3, 1. Do you know this? It's a triangular. So every time we do summation of these two, right? Now 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, then 1. And the 1, 4 is 5, 4, 6, 10, 6, 4, 10, 4, 1 is 5, is 1. So you can calculate it this way. For example, this one, this is a C, 5, choose 1, 2, or 0, 1, 2, 3. 5 choose how many? They choose 1, choose 2, choose 3, choose 3. Yeah, 5 choose 3. 5 choose 3. Yeah. Right. So it is summation of these two. So in general is C n choose K were equal to C n minus 1 choose K plus C n minus 1 choose K minus 1. And C n choose 0 is 1. Right? C n choose n is also 1. So these two lines, they are 1s. These two lines are 1s. And in the middle, the values, you can use the two numbers above this location. These two numbers to summation, you have it. So you can calculate by this way. This is a triangular. This is actually two, I think more than two guys found these triangular. In China, that is Yang Hui, Yang. This is the family name Hui, Yang Hui. That is a year, I think is 12 something years. So like around 1250, like that. And another guy is Pascal. It's a European guy. It's in the year like 16 some years. Around like 1650, like that. So this triangle was found like now it's 2000, right? Now it's 2000, so it's like 800 years ago. 800 years ago, people found this triangle to calculate this kind of numbers. Yeah. All right. Now we consider more complex case. Consider this one. We pick K from an object. We say they are A1, A2, AN, and we give the special value, specific the amount of each of these A. We want K1 of A1, K2 of A2, until Kn of AN. We want these. And we pick n objects from these. I want K1 of A1, K2 of A2, Kn of AN. Of course, here's a weight replacement, right? Weight replacement. We can pick every letter multiple times, right? Every object multiple times. So it's a weight replacement. And we want K1 A1, K2 A, yeah, like this. So totally is K. K1 plus K2 plus Kn equal to K. So like this, right? We have more details about these this result. Then how many totally amount? How many possible result? Totally amount is what? Total, right? Okay, now the thing is a combination. Totally we have k location, right? K location. We have k location. You see, all right. See, I have k location. I want to keep k1 for a1. And then after we pick this, we have another k minus k1 location. In these locations, we need to find k2, and I will put a2 in this here, in this location. So these for a1, these for a2, and so on. And the last one, yeah, we'll write one more. The next will be k minus k1 minus k2, right? We already used k1 and k2, and in the rest of the place, I need to choose k3 location. They are for a3, and so on. Right, so this is totally amount. Okay, then let me write it out. The first number, it is a k factorial over k1 factorial times k minus k1 factorial. And the second number, it is a k minus k1 factorial over k2 factorial times k minus k1 minus k2 factorial. And the third one, it is a k minus k1 minus k2 factorial in the numerator, and the denominator is k3 factorial times and k minus k1 minus k2 minus k3 factorial, and so on. Now you can see we have something can be cancelled, right? This one, right? They can be cancelled. This one, these two, they can be cancelled, and this one can be also cancelled by the rest of the numbers. So finally, we only have these left. In denominator, I have k1 factorial, then k2 factorial, until the last one is kn factorial. This is the denominator. And the numerator, we only the k factorial left. So the result is this one. Total amount is this one. Alright. Here, okay, this is also regardless the we need to consider order, with order. Yeah, that means like A1, A2, A1 is different, and A1, A2, they are different. They do not equal. Alright, you change the order, they're different. Yeah, so totally amount of different choice is this number. And we have a notation. We denote these as I put a k in the top, and then k1, k2 to kn in the bottom. Yeah, so we denote it like this way. The value will be this, and the notation this. Alright, by this notation, we have like n choose k. What is n choose k? This is n factorial over k factorial times n minus k factorial. Now by this notation is n no bar is n k n minus k. So this is a new notation. This is previously last time we introduced this notation, right? You can also write in this way. These two are same. Now we can consider example. Suppose we consider words with letter with 2 of A and 3 of B and 3 of C. How many words? Total amount is what? How many words have 2 of A, 3 of B, and 3 of C? The total length is total length of the word is 3, 3, 6, 8. Is A letter. A word with 8 letters, 2 are A, 3 letters are B, and another 3 letters are C. Then can you find the total amount of this kind of word? Okay, so this is we have 8 letters, 2 are A's, 3 are B's, another 3 are C's. Is this one? Okay, we can find the value. It's A factorial over 2 factorial, and 3 factorial, and another 3 factorial. So it is A times 7 times 6 times 5 and 4 and 3 and 2 and 1. This is a numerator. Denominator 2 factorial, and then 3 factorial, and another 3 factorial. Okay, we can cancel these. They cancel, right? And 2, 3 is 6. And the 2 here, I can use this 4. So it is 4 times 7, and 4 and 5 and 4. So it's 5, 6, 0. We have a lot. 560 different words with 8 letters. Among them, 2 are A, 2 are B, 3 are B, and 3 are C. Okay. All right. So far, all the counting problem, we just consider how many numbers can be your choice. Now let's consider more. We add the probability. We consider the case with probability. Now we consider the counting problem with probability. Okay, I use the example to explain it. Suppose we consider binary code with 6-bit. So the length is 6, right? Length is 6. So every position you need to put the 1 or 0 in it. Then we know the total amount of the code. We have 2 to the 6, right? Every place you can put the 0 or 1. You have 2 choice. Totally 6 location. Each location 2. So totally 2 to the 6. 2 to the 6. What is that? 2 to the 6. Then there's 3 to 2, right? 2 to 3, 8 squared. 8. 64. Right? Totally we have 64 different 6-bit binary code. Now we consider, suppose each bit has like a 40% chance to be 0, and of course then another and 60 chance to be 1. Okay, now we consider the probability of like one code, like the code 1 1 0 1 0 1 2 3 4 5 6. What is the probability we have this code? What is the probability we have this code? Okay, you can see the first location is 1, so we have 0.6 as a probability, right? Second location we got 1, so another 0.6. Totally we have 1 2 3 4. 4 location I have the probability each is a 0.6, right? 4 of it. And 2 locations I have 0, so the probability for 0 is 0.4. Okay, so this will be the probability you have this code. You get this code, what is the probability? It is this one. Alright. Okay. And then we can consider the probability. For example, I still use the similar thing but a different order. We consider code with exactly 2 zeros. All the codes with exactly 2 zeros. Of course, it contains a lot of codes, right? A lot of codes. Each code, the location of this 0 might be different, but the probability still be this one, right? But we have more than one code. We have a lot of code. How many code do we have? We have totally we have 6 locations. We choose 2 for zeros. That's it, right? So we have, these are the amount of code in this set, and each code has this as a probability. So we have these. Yeah, here C62 equal to the amount of these codes with exactly 2 zeros. Okay. So this is the whole amount, and this is probability of each code like this, similar like this. You have 2 zeros and 4 ones to look like this. All right. Can we have a calculate? What is this? Yeah, I leave it here. And can we have any more? Okay, we consider the code. Yeah. Okay. We can also calculate it in another way. I have 2 zeros. That means we have 4 ones, right? 4 ones. So we can also write it or like this. Totally 6. 2 are zeros and 4 are ones. And still times. Yeah, these two are same. This should be same. Yeah, you can do more calculate. You check. 6, 2, 4. This one is 6 factorial times 2 factorial and 4 factorial. Well, yeah, this is just this one. C62 is 6 factorial over 2 factorial and 6 minus 2 factorial. Right, they're the same, right? 6 minus 2 is just 4. And the numerator are same. Denominator, first one is a 2 factorial. They are also same. Yeah. So this is also same. Right? So they're same. So you use either way to calculate, you get same thing. And yeah, we can see whether the value is large or small. And 0.64 times 0.4 square. What it is? I use computer to calculate. Okay, the first one is 0.6 to the power 4 and the times 0.4 oh, it's a point to the 2. I save it. I need to use it. It's A this one. Point 0. Right. It's a 0.0207. Okay, and yeah, 0.0207. Right, 0.027. And another number is 6 choose 2 times this number. 6 choose 2, that is I think it's B equal to 6 choose 2. That will be 6 times 5 over 2. 6 choose 2 over 2 factorial is 2 and 1. It's just 2. Yeah. Then this one times A. Times A. It's 0.3. Okay, that is a C 62 times 0.64 times 0.42. That's a 0.3110. All right. Yeah. Okay. So this probability is not a small one. 31%. All right. This is an example with we pick 6 from 2. Right. You pick binary code, so you just use 0 or 1. You will pick 6 numbers from these 2 objects. 6 pick 2. Pick 6 from 2. Now we consider example like we consider now word with letter A, B, C, D, E. Right. So 5 letters, and the length of the word I like a 6. I pick 6. Yeah, I will pick 6 from A to B to C to D. And then we can consider several things, like a whole amount. How many words can we have? Then I have 6 locations, right? Each location I can choose 5, any one of it. So 5 to the 6. Right. And if we want consider like we consider the word with 2A, 2B, and one others. Then we can have this amount, right? This amount words with 2 of A, 2 of B, and totally I have 6, right? So, two others, two of C, D or E, or maybe they are same. Two others, maybe they are same. Then how many of these? So this one will be, I choose 2 from 6 for A, and then I have another 4 location. I choose 2 for B. Then the rest, how many choice? I have another 2 location, right? That two location you can choose any one of it. So 2 location. The first location you can choose these three choice, and second location another 3 choice. Right? Totally we have 9 different choice. Alright, so this will be the whole amount. That will be 6 factorial, 2 factorial, and 6 minus 2 factorial, the first number. Second number, I have 4 factorial, then 2 factorial, and 4 minus 2 factorial. And times 3 is 9. Alright, these give us 6 minus 2, that is 4. Actually, they can be cancelled. Right. So it is 6 times 5 and 4 and 3 and 2 and 1. This is numerator. Denominator, I have 2 times 1. I have 3 of these. Right. Alright, then I can cancel. These 2 can cancel. And the 2 is 4, cancel. So 5, 6, 5, 3. 6, 5 is 30. No, times 9. So equal to 30 times 3 times 9 is 9. 90 times 9 is 80. 810. We have these. Am I good? Okay. Now let's add the probability. Suppose like we have a chance for A, B, C, D, E. So okay, I want A, B, C, D, E with probability 0.2, 0.3, 0.2, 0.1, 0.2. I'm good. 5, yeah, totally 100%. So that means the words, you totally have 6 location, right? 6 words. 6. Each location, like 6. You have each location, you need to put the A, B, C, D in it. Then each place you have different chance to get A, B, C, D, E. And suppose these are the distribution of the probabilities. Okay, then we consider this one. This is 1, this is 2. 1, know the probability of the event 2. What is the probability of these? Okay, here you see we have, it will be 6 choose 2, 6 choose 4, and here we have 9 different choice. Here it's a 3 square, right? 3 square. So you have you will choose from these. Choose 2 from these. But each of them you have different probability, right? Different probability. So we can write it in this way. I have 2 location. I will choose from these 3. So I have like a 1, 1, 0, or 0, 1, 1, or 1, 0, 1. Right. We pick 2. We pick the first location. No, not 1 or 1. 2 location, right? 2 location, like this. 2 location. How to say? I will choose. Here is C, D, or E. Here will be C, D, or E. Right? and the probability CDE are these. So we have to calculate in different way. CDE, I like this. Okay, like this. I write in this way. Total is 6. I choose 2 for A, 2 for B, and I have another 3 location. I have another 2 location. These 2 location, another 3 letter. These are A, B, C, D, E. So among 6, how many C and how many D and how many E? Will be okay. That will be that. It's 101. This is the case. And 6, 2, 2, 1, 1, 0. This is the case. And 6, I choose 2, 2, and 1, 1, 0, 1, 1. Another case. So I have these 3 cases. 3 cases, right? Then these 3 cases, the probability is different. This one I times 0.2, 2 of A. 2 of A. A has probably 0.2. And 2 of B. 2 of B squared, right? Then 1 of C. No D, but 1 of E. 1 of E. Okay, this is first term. Second term times, okay, A and B are same, but C, I have no C. Then 1D, 1E. E is 0.2. Okay, I have this one. And last term, I still have 2 of A. This is B, 2 of B, and C, 1 of C, and 1 of D. Oh, D is 1. D is 0.1. D is 0.1. Okay, so the whole amount, whole probability will be this one. Will be this one. Will be this one. Then let's calculate what will be the answer. So probability of the second event, this is the event, right? Second event or B, I need to calculate these. So this is 6 times 5 times 4 times 3 times 2 times 1, 1, 2, 3, 4, 5, 6, the numerator. Denominator is 2 factorial, 2 factorial, and 1 factorial is 1, 0 factorial is 1, and 1 factorial is 1. And times, okay, I think we need a calculation. Okay, all of these contain this part, right? So we calculate these. This will be 0.2 square, 0.9 square, 3600, then times 0.2 with 72, 00, and 1 more 0. So this is a 0.00072, okay, times 0.2, the first one. And the second is this. Now is 6 times 5 times 4 times 3 times 2 times 1 over. This is a 2 times 2 factorial, and 2 factorial, and 0 factorial, and 1 factorial, and 1 factorial. And times, now is a 0.00072 times 0.1, right? 0.1. And the last one, this is a 6 times 5 times 4 times 3 times 2 times 1, and the denominator is 2 factorial times 2 factorial times 1 factorial, 1 factorial, and 0 factorial, and times 0.00072 times 0.1. Okay, so we calculate this one. I have 2 and 2. I can cancel with this 4. Then I have 5, 6, that's 30. 2, 6 is 6. So this is a 180. 180, right? So it's 180 times 0.00072. Okay. All these three numbers actually they are same. You see, numerator are totally same. Denominator just yeah, it's also same. This is 1. Sorry, 1 factorial. 0 factorial is still 1. Right? Okay. Here. 0 factorial is 1, and 1 factorial is also 1. Okay. So all these are 180, and these are also same. So everything is this different, right? Okay, what it is? This one I need a calculation. I use this 180 times 0.00072 and times summation. This is a 0.4. Okay, this is a 0.051a. Oh, it's not too much. This is just 5%. 2A, 2B, and 2 others. It looks like this. The probability. So we have a probability. All right, and we can have. Yeah, is it good? Yeah, we can consider a little bit simpler one. Actually, we consider this is 1, 2, 3, and 4. We consider probability of this event. We consider the worst ways. I have A, B, C, D, right? With 2B and 1 of each others. 1 of each others. Right. We have A, B, C, D. We have 5 letters, and I use 2B. Use B 2 times, and A 1C, 1D, 1E. Right. Then okay, it will be the amount. How many? We have 6. Then 1 of A, 2 of B, 1 of C, 1 of D, 1 of E. And the probability, 1 is A. Where's the probability? Let's see here. 1 is A, 0.2. Okay, we have this. 1 is A, 0.2, and 2 are B, so 0.3 with square, and C is 1, D is 1, and E is 1. Alright. So we have these as a probability. It will be 6 factorial over 1 factorial. 1. Okay, all this 1 factorial is 1, so I only need 2 factorial here. And this side I have 2, 2, 2, so I have 3 of these 2's. It's 8, right? And this one is a 0.09. So this is a 6 factorial. 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, and here's 8, 9 is 72, right? 72. And before that we need 3 zeros. Point. Am I good? Okay, so what it is? 2 cancel. This is 30. This is 12. So that is 360 times 0.00072. What it is? This is 360 times 0.00072. This is 0.2592. Oh, am I good? It looks like too large. 2b and 1 of each. That one is 2a, 2b, and 2 others. This is quite small. This one, or maybe this is not this one. This will be a. Maybe this should be even smaller. Let me see. Let's try this. 0.2 times 0.3 squared. Okay, just like this. 0.3 squared and times 0.2 times 0.2 times 0.1. Well, I need okay, so what it is? It's a anyway. I times 300 times 3. I times 360. 0.0. Okay, I missed 1 0 here. So here should be 4 zeros. After that, I have 4 zeros. 1, 2, 3, 3, 3, 9, 2, 2, 2. Oh, here's a point 1. I missed this. Yeah, times 0.1. Okay. So here's one more point. One more zero after point. Okay. So it is 2%. So 2.5%. 2.5%. All right. Okay. That's all for today. This is this is for counting, and also we can consider the probability. So if when you have different object, and each object they can occur with kind of probability, you can also calculate the probability of the event, right? So this is what we studied today, and see you next time.